Foundations of Amateur Radio. Antennas and propagation are the two single most discussed topics in our hobby. That and how an FT8 contact isn't real. Not a day goes by without some conversation about what antenna is the best one and by how much. In my opinion, it's a futile effort made all the worse by so-called experts, explaining in undeniable gobbledegook, or sometimes even using science, just how any particular antenna is a compromise. The truth is that most conductive materials radiate to more or less a degree. Sometimes there's enough of that to make it outside your backyard, into the antenna of a fellow hobbyist. To make a point, as is my wont, over the past months I've been conducting an experiment. It's the first in a series all related to antennas and propagation. As has been said, the difference between fiddling and science is writing it down, so this is me writing it down. I'm using the tools available to me to explore the various attributes of my station and how it affects what's possible. I will observe that this is within the dynamic nature of the environment, so the solar cycle, solar events, thunderstorms and noise are making an impact. No doubt I'll create a visualization that links some of those extra variables, but for now I'm just noting that these external events affect what I'm doing. You might recall that I took delivery of a whisper beacon a few months ago. If you're unfamiliar, whisper or weak signal propagation reporter is a tool that allows a station to transmit a time-synchronized signal on a specific frequency, so other stations can look for and attempt to decode it. Think of it as a timed Morse code signal and you'll have a pretty close understanding of what it does. The beacon I purchased was a 200 milliwatt Zactec 80-10 desktop transmitter, built by Harry Sierra Mike 7 Papa November Victor. It can operate on all the HF bands I'm licensed for and can run all day, every day. It's time synchronized using a supplied GPS antenna and powered by a micro USB cable. It's currently connected to my vertical antenna. That vertical antenna is a homebrew helically wound whip, tuned for the 40-meter band, clamped to the side of my metal patio roof. It's fed by an SGC 237 antenna coupler, which is held by magnets to the roof. A 75-ohm RG6 quad-shield coax cable about 20 meters long, left over from my satellite dish installation days, is connected via several adapters and coax switches to the beacon. This is not a fancy setup by any stretch of the imagination, but it's my station and what I use to get on air to make noise, and that's the whole point of this exercise. You might recall that one of the reasons I want to learn Morse is so I can hear an NCDXF beacon and know which one I'm hearing on my own station. In many ways, this is a different way to approach the same problem. Said plainly, how do I determine what propagation is like for me, right now, on my own gear? There are countless tools available, from the Voice of America VOACAP propagation prediction through the graphs and charts on clublog.org to the space weather services run by the Bureau of Meteorology in Australia. All of these tools have one thing in common: they don't use your own gear. Unsurprisingly, you're likely to wonder what it is that I can achieve with a mere 200 milliwatt transmitter and a vertical. Turns out, quite a lot. As of right now, my whisper beacon has been heard multiple times over the past 3 months in the Canary Islands, over 15,000 kilometers away. The watts per kilometer calculation puts that at over 76,000 kilometers per watt. Not bad for a little amateur station located in the middle of a residential suburb. Did I mention that this was on the 10-meter band? I was asked if I would put a pin in my DXCC map tracking the countries for each of these whisper reports, and my answer to that is no. This is not a contact, this is a propagation ping. I suppose that I could, if I really wanted to argue the point, which I don't, use a pin if I had a reciprocal report from the other station within a set period of time. But that's not why I'm doing this. The purpose of this exercise is to discover what my station is capable of, what propagation is like, how it changes over time, how uniform my radiation pattern is, and how much of the globe can hear my signal. One observation to make is that much of the west coast of the United States is a similar distance away from me, but so far there are no reports from that continent. As a quick and dirty test, I'm using my Yaesu radio and 5 watts for the next day to see if this is an edge case or if there's something else going on. For example, my house has a peak metal roof to the west of my antenna. Is it possible that it's affecting the radiation pattern, or is there something else going on, like the neighbour's house that sits to the east? For all I know, the noise floor in the Canary Islands is significantly better than anywhere in the USA, but only time will tell. I've recently taken delivery of a multiband vertical antenna which I'm planning to use to replace my current vertical. The main reason being that my antenna coupler cannot tune with 200 milliwatts, and to do band hopping I'd have to retune manually each time, not something that's sustainable 24 hours a day. No doubt that change will bring other discoveries, but then I'm keeping track. The intent of all of this is that you can experiment with your own station, test ideas, trial a setup, keep a log, and discover new things that your station presents to you. Amateur radio is never just about one thing. It's always a dozen different things, all at the same time. What are you going to discover next? I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.